Hey guys, and welcome back to a new video. In this video, I'm going to show you how you can implement pagination with Jetpack Compose, because that's something I actually never did here on YouTube. And while many will wonder why I won't use the paging library from the Jetpack one for this, because that also exists for Jetpack Compose, the simple reason is that I don't like it. For those who actually watched my Twitch live streams in the past, there I dealt a lot with pagination, and there I found out that I don't like the paging library. The reason is that once you actually get a list using the paging library, it's very hard to actually modify single items. So the scenario I had there was that I had a bunch of posts, so social media posts, and those were paginated. So I got those paginated from the API, and when I actually wanted to like these, then I wanted to change the color of the like heart to simply a green color to indicate, hey, this post is liked. And it was really difficult to actually do this with the paging library because we don't really have a compose state, like just a normal list of items that we can manipulate. No, instead, there's some different ways the paging library manages that. And that's why I actually have my own approach of doing that, which I will show you here. It's universal. You can just take it, copy it into whatever project, and it will work. You just need to do some minor adjustments, and I will now walk you through this, how it looks like, how it works, and then you're ready to go, and you have a very fancy and well-performing pagination solution for all of your projects. So for this tutorial, we will just simulate a remote data source and a little bit of delay to load these, but of course, if you have an API, that will work. If you have a database, that will work. But the specific implementation, how you paginate with a database and API, of course, strongly differs on what you choose. That's why I will just choose a very simple approach here of simulating a remote data source. You can see we have a bunch of items, and when we scroll to 20, it will load more items. And then we can see this here, load more items, 2-second delay every time. And when we're actually arrived at 100 items, then we will see the spinner one last time, but it will then see, okay, there are no more items. So it will actually stop paginating and stop loading. And then we have our cool list here, which is just a normal state in Compose, just a normal list that we can also change. We can delete items afterwards. We can add more items to this list independently of this paginated list. So it's really efficient and really, really nice to work with that. So to start with this project, I added a little bit of initial setup here that's not really related to implementing pagination. That's why I don't want to show you that on the video. Just a repository that simulates this delay. You can see we have a remote data source. It's in the end just this list of 100 items that we want to paginate here. So 100 list items with an item title and an item description. You can see I have this data class here. And then we have a suspend function get items. So that could just be your call to the API in your repository. That could be your call. That could be your call to your database. It will take a page in form of an integer, so 0th page, 1st page, 2nd page, and a page size. So how many items you want to load. The cool thing about this approach is that's just like with the paging library. You can choose anything for the keys of the pagination. So in this case, the key would be the page. And that would be an integer, but some APIs actually use some kind of token strings, and you need to provide the next token string if you want to make the next request and stuff like that. So that's really flexible with my approach as well. So you're good to pick that one. So it doesn't only work with integer pages. That's what I'm trying to say here. Then this function will return a result. So just this Kotlin result class, which can either be a success or an error. I don't return any error here because it just succeeds every time. But if there is an error, my solution will also, of course, handle this. And every time we paginate, we just slice our list to simulate the next response. So we get the next chunk of list items. And you can simply find this initial setup down below my GitHub repository, and you will also find the final source code there if you have any issues. But I would suggest we just jump right into it and start creating our, not our view model first. I actually want to create something called a Paginator that will actually perform the pagination. So Paginator, select interface. Let me add that to Git, and this interface will just specify what one paginator should be able to do. In the end, that should just be a function to load next items. So whatever kind of paginator we have, it should always be able to load next items, of course. And there should be a function to reset it. So if we want to start all over again. And this paginator will actually be a paginator of type item. So we will have a generic type parameter here, which will basically describe the items, the type of items we actually want to paginate. So in our example, that would be a list of list items. So item would be a list item. And then we're actually ready to create an implementation of this interface, which specifically now, which is a concrete implementation of how we want to paginate something. And this is a little bit more complex class, but don't worry, I will go through it step by step and it will then be easily understandable. I'll call it default paginator. Select class here. And that will now actually also have generic parameters. It will have two parameters here actually. Not only the item, but also the key, which I also mentioned already in the repository. So the key would be based on what kind of value we actually paginate. So in our example, the key would be an integer here because we paginate based on pages. So that's how we determine whether a new page is reached or not, or we provide for the API that it knows which page we want to load. But as I said, there might be APIs that use some kind of string tokens to give you the next data. There might be some other values, so you can choose anything you like. That's why I make this parameter generic. So we will have a key and an item. The item you already know. We can actually also provide the key for the paginator. I don't see any reason in not doing this. Just like this. And then here we will have a constructor that will be quite large because it will have a bunch of callback functions. On the one hand, it will have a private val initial key. And that will be of type key. So that will just be the initial page we want to start with. So for example, 0. So just what it will provide to the API to load the very first page. So the next function, the next parameters will all be functions, lambda functions, that will give us some callbacks and in which we then need to kind of adapt this default paginator to our use case. So to our API, for example. We'll start with a very simple function that's easy to understand. Private, actually inline val, those will all be inline vals, on load updated, which will give us a Boolean and return unit. So that will just be a lambda callback that is called when the loading value is updated. So either if we are loading the new items or if we finished loading the items, so we can then show a progress indicator in our UI. If you don't know what inline means, that basically is just a little compile time optimization here. It's not mandatory, but if we use it, then what the compiler will do is it will basically take the code from this lambda function and directly copy it to the place where we call this function here in our default paginator. So technically there won't be any new real function that we create here. Instead, it will just copy code over to this place here, which is a little bit more performant, a little bit more memory efficient. Just something we should do here and nothing to worry more about. Then we will have another private inline val, which will be called on request. So this is actually the function in which we define how we get the next load of items given the key. So we will get this key here from the default paginator. And based on that, we then need to actually tell this default paginator, hey, I'll take this key, and this is how you actually get the new data with this key. So the result here, so the returning value of this onRequest function will then be a result. So this Kotlin result object that I showed you here in this repository, with which we can just distinguish between success and error. So if you would have an error, then you would have a result failure and you pass a throwable. If you want more freedom in regards to what you can pass here, if you don't want to just pass a throwable, but also maybe an error message or some kind of other value, then you need to create a custom class for that. Many will know that I like to create a resource class that is just simply a Kotlin sealed class to wrap around a specific result. That will also work, but because I don't want to create this here in this tutorial because it's not too related, I'll use this Kotlin result API. And this result will be out of a list of our item type. So in our case, we have a list of list items. And we return a result out of list items. So this list item is now here our generic item type. If you have a different type of item your API returns, then you of course simply pass that instead. And since it's generic, it will work for any type of item. And also something we need to consider here is that we actually make this suspending. So this function is a suspend function, and we can call coroutine the suspend functions in it, so that we can actually also do this for APIs, databases, and stuff like that, because that's typically what we want to paginate, right? Cool. Next function, next callback will be a private inline eval get next key. So we of course need to specify some kind of logic how we can get the next key, how this default paginator knows, okay, that is the next key. For our example here, if we simply paginate based on pages, that's very, very easy, because the next key is just the current page incremented by 1. So just a page plus 1. But if you have some kind of other value, like a string, as I said, then there must be some kind of logic. Maybe you get that from the old API response, that it just contains, okay, here's the next key. That's how you load the next bunch of items. And then you need to provide this to this function. So this will also be suspending, will contain a list of items, because as I said, this list of items might actually contain the information about which page you want to load next. And it of course does not return unit, instead it will return the key that it now showed load next. And then we have two more functions left. On the one hand, an onError function, of course, when an error happens. Suspending will return a throwable here, in this case, like not return it, just provide that as a parameter, does not return anything. And as I said, if you have your other kind of implementation without throwables, you can pass anything to this onError function, of course. I'll leave it at that. And one last function is a private inline eval on success, the function we're actually interested in the most. When we successfully loaded some items, it will simply give us the list of items, which we of course want, like a list of item, and it will give us the next key, or the new key rather. So we can also update the current key, the current page in our state later, and does not return anything. Cool, looks quite complex here, but we are already halfway done here with this default paginator. We need to make sure that it implements our interface with our key and item. And then we can press Ctrl-I to implement our two functions, load next items and reset. And load next items is actually a suspending function, I'm just realizing. So let's switch back to our paginator and make this one suspending. This one as well. And then we actually need two member variables. On the one hand, that is a private variable current key. So that just stores the current key. So the current page, for example, that we're loading is null by default, because we will get the initial key here from this variable. In the end, we can also use initial key here and remove this nullability. Just like this. Yeah, that should be fine. And one more variable that's just there to prevent a little bug, and that is called is making request. That's false. That will just be true as long as we make the request to our API, to our database, just to prevent a little issue of loading two pages at once. If we quickly call this function one after another, which sometimes happened with the approach that we have to choose here, but with this Boolean, it simply does not happen. So first of all, I want to then check if we are currently making the request, then we just don't want to load the next items. Then we just want to ignore it and wait to till the next load next items call. If we aren't, then we can say is making a request is now true, because now we are making the request. We want to say we update the loading status to true. So we now start loading. And then we can get the result using our onRequest function, where we can simply provide our current key as the next key that we want to load. After that, we can set isMakingRequest to false, because yeah, that's a suspending call, and we will resume here once we made our API call. And then we can say result dot on, actually not on failure. We want to say get or else. So we actually get the items here from this. So if everything went well, this get or else function will just return the list of items. If it did not run well, then we get the throwable here, so the issue that actually happened. In this case, we of course want to call our onError function with this throwable. We also want to say onLoadUpdated, set it to false, because now we're not loading anymore if we got an error. And we want to return out of our load next items function, because yeah, we don't want to go on here if we really got an error. However, if we didn't, then we can see that we now have a list of our item type. And that is very cool, because now we actually have what we want. So if that was successful, we want to update our current key with the next key, with the function that we provided, passing our items list, and we want to say on success with our items list and our current key. And we also want to say on load updated false. So we're not loading anymore. We pass our new items, so that is just the new chunk of items to the onSuccess function, and we are pretty good. In reset, that's really easy. We just want to say, okay, the current key is now the initial key again. Cool, that's really it for this paginator. Let's now create a little view model that accesses our repository to actually make use of this paginator class to actually perform the pagination. So in here, new class called main view model, whatever. Oops. Make that a view model. And first of all, I want to actually have a data class for our screen state. So just a class that summarizes all the state that we want to, that we need to display our results. On the one hand, that is an loading boolean. That's false initially. We have an items list, which is a list of list item. Empty list by default. We have an error message, which we want to set to null by default. We want to have a boolean whether our end is actually reached. So the end of our list of our pagination is of course false initially, and we want to have the current page, which is initially 0. So that's just our screen state that describes also the state of our current pagination. In here, we will then have our state just in form of a normal compose state. Screen state, just initialize that here, import these values here. And we will then have a private val Paginator, which is now of type default Paginator. And here we now need to implement our bunch of functions. First of all, the initial key is just state.page. So 0 in this case. Onload updated. So what do we do if we trigger this onload updated function with the new loading state? Well, we just want to say state is state.copy, and we set is loading to whatever loading value we got from our paginator. Then we get on request, which gives us the next key. So next page in this case, because it's an integer. And we now use this to use our repository, which we don't have yet. Normally I would put this in the constructor of this view model, but this makes things more complex. So I will just have a private val repository here, because we can directly create it here. In a normal project, you should use dependency injection, of course, and provide this in the constructor. Gives you a lot more flexibility than this approach. But for simplicity reasons, let's just use the repository here and get the next bunch of items, providing our next page. And well, for the page size, I'll just choose 20 here. So we load 20 items at once. Then the next function will be get next key. So how does that look like? Here we get a list of items, which we don't need here, because we just need to tell our paginator now how it can get the next key basically, and that is just using our state.page plus 1. So we just load the next page. That's really easy. Then we need an onError function. Here we get a throwable. And we just want to say state is stated copy, and we set our error to it. Localized message maybe. Of course, in a real project, you can do some more fine-grained error handling. I'll just leave it like that, because that's really not the focus of this video. And we finally have onSuccess, in which we get the new items and the new key. And here we just also want to update our state. We want to make sure that we set the items list to our current state items plus the new items, because this will just be the next 20 items the Paginator loaded. We just want to append these to our current items list. And the page will now be new key, and reached will be whether our new items list is empty. So if the API does simply return an empty list, that means in my case here that there are no more items to be loaded, so our end is actually reached. And now we only actually need to trigger this function here, load next items, when we want this. So we will have a function for this, load next items, which will just launch a coroutine in ViewModel scope. And in here it will call Paginator load next items. Since we want to initially load these items, let's call this function in init, load next items. But we also, of course, want to call it when we scroll to the very bottom. So let's jump into main activity next and implement our little list of items. So normal lazy column, where we want to say modifier fill max size. And in here, we're going to have a normal items block. We need to specify a count of items we have, and that is simply our ViewModel states item size list, items list size. So let's get a reference to the ViewModel using ViewModel. And for that, I already included the dependency here in build.gradle. So in case you did not get the initial source code, make sure you have this dependency. Will be of type main ViewModel. And missing an angle bracket here. We can get the state from ViewModel.state. And then based on state items size, we will get our index here. So the index of the item that is currently composed here. We can get the item in our list in that case. So item is equal to state items at the index of I. And then we actually want to have a little column for each item. So we say modifiers fill max width, giving it a little bit of padding, let's say 16 dp. And yeah, that's already it for this column. Let's go in here. Have a little text for the title of the item is item.title. Let's say the font size is 20 sp, import sp, and let's set the color to black. Adding a little bit of space. ATP, and another text for the description, where you can just say item.description. Nothing really special in terms of compose here. How do we now actually detect if we are at the very bottom of this list? Well, that's really easy. We can just check here, directly in this items block, if our I is greater than or equal to our state items size minus 1. So I will be the index of the currently composed item. And if that is our very last item of our list, we know we actually reached the bottom. But we also, of course, want to make sure that we did not reach our end yet, and that we're also not loading any items. Yeah. So in that case, we simply want to say ViewModel load next items. And yes, strictly speaking, this would be considered a side effect. So something that leaves the scope of a composable function. However, in this case, I think this is actually fine. So first of all, the issue of side effects is that we don't have the direct control of how often this block of code is called, because the Compose framework calls it. And theoretically, it could call this if statement in times where we don't want it to be called. However, with this condition, we really make sure that we really only load the items when we really want to load it. So when we're not currently loading, if the end is not reached, and if we're at the bottom of the list, and then this is fine. I think this is the easiest way to perform pagination in Jetpack Compose, so feel free to use this. However, yeah, what we now want to do is we want to also have a loading indicator. So that will be enough to perform the pagination. But below this items block, here, we want to have an item block. So for a single item. And if we are loading, we simply want to have a row with a progress indicator. So, whoops. Modifier is modifier fill max width. And we make sure, actually, that we also give it a little bit of padding, ADP. And we say horizontal arrangement is center. And then in here, we can just put a circular progress indicator. Cool. That's it. That's how we paginate something with Jetpack Compose. Pretty easy, I think, if you have this Paginator class. It might need a little bit of adjustment here, depending on how your pagination works. So as I said, I mentioned an example where some APIs give you the next key in the API response. So you basically make the request, say, okay, I want to load the first page. And then in that request, there's some other key or token that you need to use to load the next page. And if you need that for the next key, then you're not just fine providing this list of items here for the get next key function. Instead, then you need to provide some kind of a response object you get from the API here or so. But that should all be a very quick change and very quick adjustment. Overall, for most scenarios, this just works very well. You're totally free in manipulating what you got from the API, what the paging library does not allow you. And I would say we just try this out, run this on my phone, and switch over here. This is still the old app. Let's wait until the build actually finishes, and then I'll see you back. There we go. The first load is showing. We have our items. When we scroll down, you can see a progress indicator, next items. We can load again. And is that, yeah, that's working fine. It was just a little bit laggy. It looked like it loaded some items twice, but it didn't. And loading the final items here. When we arrived at the end, we can't go on. And of course, yeah, if we rotate the device, then everything will stay intact because we store it in a view model. So then we don't need to load everything again, of course. Exactly how it should be. So I hope this was a helpful video. And if you actually also love coroutines as much as I do, and you use these for your network calls, for your API calls, then you definitely don't want to make these mistakes that I described in this video. 5 mistakes that most people do when using coroutines. Enjoy this video, it's really important.